That's fine. Let's see if this is working. Can you hear me? Yes. Okay, great. That's working. So if you are a virtual person watching this back, this is your bell ringer. Make sure you copy that down. Do y'all have 7 bell ringers? I think you should have 7 at this point. Y'all check that for me. Make sure there's 7, and then I'm going to pass y'all papers down. 7? Okay. Also, Old Navy released all these Christmas masks. Of course, I'm like looking at them thinking which Christmas mask should I get, and then like part of me is like, what even is life right now that I'm like trying to figure out what kind of Christmas mask I'm gonna get. Never thought that was a thing. Your politicians need to stop.
Yeah.
We get all these coronavirus.
I'm a politician. So I'm like, this is still a thing. Right. How could you be a president?
I-
35.
No idea.
You don't know? Yeah. In 20 years.
Surely not.
Sure. I think it'd be like.
As a president of the United States?
Yeah. No.
Oh my gosh, I didn't know what I wanted to do at 28 years.
I think we'd be right versus college
Like, there's like a cap. Like, you gotta be 70 or not. I was thinking 60.
You are on the verge of dying.
Yeah. Yeah. Next year you're gonna be.
But you never know. People die young too.
Well, yeah, but I mean.
Let's not get political. Let's not get
There should
political.
be a cap. I mean, like 65 cap.
Okay.
If you think about it, both candidates this year
Yeah, everyone's old this year.
have like.
Youngish, yeah. I like that 40-ish youngish to you. That makes me feel really good. That means I'm like real young. Like a teenager. Close. All right, okay. This is a reference sheet. That's why I printed it separate. Okay, it's by itself. It's something that you're going to need to keep out and have so that you can refer to it when you need it. And you guys are taking your quiz in class this week, which means you will not be able to use your notes. So I will consider maybe letting you guys use this if it's blank. like you write what I write, but don't write anything else, okay? Hey, I know I let some of y'all eat your lunch in here, but we're going to have to quit, okay? Because we're like now spending like an hour and a half together with our mask off. So, y'all, let's wait till lunchtime to eat our lunch, just in case I hate for it to be my class that we all, everyone in Miss Cole's 4th hour has the coronavirus. That would be horrible. Okay, so, all right, if we look at this, prove that triangles are congruent, okay? So we are doing that in the form of a 2-column proof, okay? Just like we have equations, we're going to be doing that with congruent triangles, but we need to have the reasons why you know that things are congruent, and you have 1, 2, 3, 4, 5 options, okay? So if we look at the first one, the first option is side, side, side. If you have 3 pairs of congruent sides are congruent, then you know your triangles are congruent. And we're going to see some examples of that today. This SSS is going to be like one of your final reasons. Like, because you know all of the sides are the same, okay? Then it's side angle side. It has to be the included angle. So underline that, must be included. You can know this side and this side, these sides, but you have to know the included angle, the angle that joins those 2 segments together. If you know the included angle, then we call that side angle side. And it can also be a reason why your whole triangle is congruent. Okay, just knowing those 3 parts proves the entire triangle is congruent. Now, on this one, it's SAS. Okay, so SAS is 2 angles in the included side. So this time you could have the angle here and the angle here. And you'd have to have the included side. So that's the side in between those 2 things. Okay. Then we have angle, angle side. That is when you have 2 angles, just like before, but you have a side opposite them. So not the included side. So the opposite side is any side that's not included. So again, we could still have these 2 angles, same angles as before. Could be any 2 though. Any 2 angles, and a side opposite is just a side that's not included. So it could be this side down here, or it could be the other side over there, but just not the. Then the 5th one is only for right triangles. Okay, so our right triangles have a special thing. Instead of having to know 3 facts, you only have to know 2. You have to know that the hypotenuse is congruent to the other hypotenuse, and then just legs. So like this leg would be fine. Knowing those 2 things allows us to know that we have a right triangle. I mean, not a right triangle, a congruent set of triangles. So those are congruent. So these are going to be our choices that we're going to choose from. And we're going to work our way through them this week. Okay, and we're going to get through that throughout this week. But you don't use but one at a time. Okay, so when you get ready to do this, you're going to be using one of these at a time based on the information that's either given to you or that you can inquire from what was given to you. So when you write out a 2-column proof, you're going to have 2 columns. One column is going to be the statements. The other column is the reasons. So sides are congruent. And there's only 3 to choose from. So really that's not that big of a deal. So when you're filling in your 2-column proof, these are the ones that you can choose from. Either the given, it being the midpoint, or the reflexive property. Remember, the reflexive property is when something equals itself. So like, for example, you could have side AB equals AB. That's the reflexive property, when it equals itself. Or if it's an angle, angle A equals angle A, then that would be the reflexive property. Okay, so those are examples of the reflexive property. Now, reasons angles are congruent. So you got some more options on those, but remember, these are going to go in that 2-column proof, and you're going to choose from one of these. Either it's given, they're vertical angles. All of these have to deal with parallel lines. So if it's not parallel lines, you can't use that one anyways. Okay. And then you could use the angle bisector, because remember, a bisector cuts it in half. Okay, so we can use all of those. Now, corresponding parts of congruent triangles are congruent. We learned about that last class period that I've taught. We learned about CP/CT. We will be using that with the we need to. Triangle ABC is congruent to triangle DEF. Then they want us to list these out. AB is congruent to who? DE. BC is congruent to EF. And AC is congruent to DF. Everybody okay with that? Then you also have angles. Angle A is congruent to B. Angle B is congruent to angle E. And angle C is congruent to angle F. So once you've taken one of the reasons at the top and proven that you have congruent triangles, then you can apply the fact that now all of the parts are going to be congruent. So let me show you exactly what I'm talking about with the next page. So go to the next page, and today we're going to be working on the proofs. All right, we're going to be proving that these are congruent to one another. Okay, that we're dealing with congruent triangles. As of right now, you can't assume. You have to be able to prove it. Now, we're going to be focused on 2 of these. Okay, side, 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 and side, angle, side. That's what we're working on today. So if I look at this first one, you can see they've got their 2 triangles. This is just our rule box. It says if 3 sides of a triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So let's write this out quickly. If AB is congruent to DE and BC is congruent to EF and AC is congruent to DF, then triangle ABC is congruent to triangle DEF. And remember, it does matter how you write. You got to write the corresponding parts with the corresponding part. They have to. Okay, so here's some samples of side, 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 and what that is actually going to look like. Here's your situation. They're going to give you an image. Usually, they'll give you an image. I guess they don't have to, but usually they give you an image, and then they give you some information and ask you to prove something. Well, we want to prove that triangle PQR is congruent to triangle STR. So the first statement they have is that segment PQ is congruent to segment ST. What's the reason for number 1? Given. Then it says segment QR is congruent to RT. That's number 2. So what's that? Given. Then it says R is the midpoint of segment SP. So what's that mean? Or what is this? Still given. So we have 3 given things. They told us that PQ and ST are congruent. They told us that QR and RT are congruent. And they told us that R is the midpoint. So since R is the midpoint, what do we know about PR and RS? You know they're congruent. That's the next statement. PR is congruent to RS. Well, how do you know that they're congruent? That is the midpoint of segment PS, which means the 2 little segments are congruent. Now, this is how I help figure out what's going on if they're lost, okay? If you look at this congruency, see the equal sign with the wave over it? If you look at this congruency statement, they are talking about a side, the segment, so it's a side. This congruency statement is talking about a side. This congruency is talking about a side. So how do we know that triangle PQR is congruent? Side, side, side. Remember, if you know that 3 sides are congruent, then you know that the whole is congruent. That is a way that we can prove congruency. Knowing the 3 sides allows you to know that they're congruent. All right. Number 2. The first statement, segment JL is congruent to segment ML. How do you know that? How do you know that's the midpoint? They gave it to you. It's given. We are trying to prove triangles are congruent. That JK is congruent to KN. JK is congruent to KN. Well, how do you know that? Good. Definition of midpoint. How do you know that LK is congruent to KM? Good. Definition of midpoint. Then the last thing says, how do you know that the triangle is congruent to the triangle? Side, side, side. And again, these are easy because they're all like, this whole section is about side, side, side. You know it's going to be side, side, side. But when they jumble it up and they mix it all up, go and look at the congruency statement. Congruency statement here is a side. Congruency statement here is a side. Congruency statement here is a side. It has to be side, side, side. All right. Now, number 3 is from scratch. It is a blank proof. So when you get a blank proof, what's the first thing that you're going to do? Yeah, write your givens. Okay. All right. So the given AC is congruent to AD. That's given. And I'm going to mark it up here so I can see what we're dealing with. The next given is CB is congruent to BD. That's given. If you can't do anything else on your test but write the given in, you can at least write the given in and give yourself some points, okay? So right now you have 50% of this problem done just by writing the givens in. So everybody can do that, okay? Students get so overwhelmed by proofs, but really, I mean, some of the points are pretty much free. You know it's going to be the given, so you just write those in. So that was what, CB and BD. What do these triangles share right there in the middle? Do you see that they share that segment? Anytime they share a segment like that, you can say AB is going to equal AB because it's shared. So since AB equals AB, what's the reason that we get to use that? Good. This is an example of the reflexive property. Anytime you see triangles sharing a segment, you can use that as part of your proof. Okay, so anytime they're sharing, use that as your proof. All right, so now what goes in box number 4? Good. The proof should always be your bottom box. So up here, we're trying to prove this. Well, that should be your bottom box. These always end up being at the bottom. So what's the reason that you know those triangles are side, side, side? Now, nothing changes except for instead of us using 3 sides, now we're using 2 sides and the included angle. So we've got this included angle that we're using. So let's write this out quickly. AB is congruent to DE. Angle B is congruent to angle E. And BC is congruent to EF, which means triangle ABC is congruent to triangle DEF. It has to be included. That's the most important part, Connor, right? Has to be included. Has to be in between the sides, or else it's not angle, side, angle, side. It could be something different. But in order for it to be this one, it has to be that included angle. So here's some examples. Now, the first thing I see when I look at this is I see they're sharing this. So I know somewhere in this proof, we're probably going to have the reflexive property. Anytime you see the triangles sharing something, know that that's probably going to be used. But we don't even have to guess. They gave us the statements. So since they gave us the statements, we just have to fill in the reasons. What's number 1's reason? It's given. It's right there at the top, given. What's number 2's reason? It's given. So they told us that JM and NL are congruent. So I marked that. And then they tell us that JMN, which is here, is congruent to LNM, which is there. Then it says MN equals MN jet. Y'all, put your cell phones up. I'm so nice. I'm about to change that if y'all can't get it together. MN equals MN are not equals, congruent. How do you know that? Good, that's your reflexive property. They share that. That's the reflexive property. So how do we know that the triangles are congruent? It's not side to side. SAS, because this statement, look at the congruency symbol, is for a side. Look at this one though. This is the first one that we've seen that's not a side. Do you see that it says angle is congruent to angle? So this is an angle, and then this is a side. So angle, so I'm sorry, side, angle, side. Flip it over. All right, look at number 5. Okay, AB, segment AB is congruent to segment BC. What do we know about that? It's given. BD bisects angle ABC. What's that? Before we go to the next one, what do you know about an angle bisector? Splits it in half. So they're saying that angle ABD, this little angle there, is congruent to CBD, this little angle here. How do they know that? Good. Definition of angle bisector. And if you didn't know that, you have your reference sheet. Your reference sheet has your reasons, okay? It was not given. They are not vertical angles. We do not have parallel lines. So literally the only option that we had left was angle bisector. So these are the reasons that you have to choose from. That makes it very easy. So angle bisector tells us that. And then it says BD equals BD. That's the reflexive property. They share that. So we have the side on the outside, angle right here, and this side here. Do we have the included angle? Side, angle, side. It's like if you had to pick up your pencil, it would have to be like you can't pick up. So you've got side, the included angle, and the side. So that definitely works for side, angle, side. Okay, you try the next one. Try that one on your own. Everybody's working. All right, so what's number 1? Given, which tells you that you have a midpoint, that V is the midpoint. How do you know that WV and VZ are congruent? Very good. Definition of midpoint. How do you know that the angles are congruent to themselves? Good. Those are your vertical angles. They touch noses, so those are vertical angles. Then it asks about the other sides, XV and VY. How do you know that those are congruent? Good. Again, the definition of midpoint. So how did you prove that those are congruent? Side, angle, side. All right, let's do this last one together so we can finish it up. It says HI is congruent to GI. That's given. HI is parallel to GI. That's also given. Now, knowing that they're parallel, y'all, look, that opens up a whole new level of reasons because we have parallel lines. Anytime they say parallel lines, you can use these three options. So it says angle GJH, GJH, this angle, and IHJ are congruent. How do you know? Alternate interior angles. Do you see how they're, like, if we extended this transversal, do you see how they're on opposite sides of the parallel lines? Those are our parallel lines. Can you see that image now? Okay, so these are alternate interior angles. What about HJ being congruent to HJ? They share that, so that is your reflexive property. I've spelled it both ways. It's with an X. I misspelled it somewhere else today. Oh well. Reflexive property. And then triangle GJH is congruent to IHJ. What's that? Angle side. This one, because that's not a congruent. Only put a letter beside the ones that are congruent statements. If they're not congruency statements, we don't put it on there. Now, you do have homework tonight, but you're only doing certain ones tonight, and then you'll do certain ones on Wednesday. So this is kind of a two-part homework assignment. So I'm going to hand this out to you, and then don't put it up until I tell you exactly which ones to do. And don't X out the other ones because you will do everything on the sheet, just not all tonight, okay? One tonight, yeah, you'll turn in tonight. And I told the last class that I would extend it because if everything was normal, you wouldn't turn this in until Wednesday. So they convinced me to give you another day. But I would just do it and get it done, turn it in. Anytime I end up being a slacker, it ends up, I forget to do it or something like that. So today, the whole day was spent on proofs. So that's what you're doing for homework. Okay, your homework problems are 7, 8, 9, and 10. Just those 4 problems, 7, 8, 9, and 10. So do those proofs, take a picture of it, and submit it to me. Okay? Yes, just the ones that we went over today. My guess is that there's 2 of each, but I honestly don't know. All right. We got anybody zooming? No.